Okay, this image shows a wave that's traveling towards the right. Here you can see the wavefronts, and it's all encountering an obstacle, and when it encounters the obstacle, it's going to spread out like this. This effect is known as diffraction. So diffraction is a bending and spreading out of wave around an obstacle or a gap. Okay, here we've got an obstacle and it's spreading out from both ends, and then here it's going through a gap and spreading out. This is called diffraction. It turns out maximum diffraction occurs when the size of the gap or obstacle is equal to the wavelength of the wave. Okay, so here we've got the wavelength, which is indicated by the distance between the wavefronts, and we've got the gap here. And because the gap size and the wavelength are roughly equal, we get maximum diffraction. Now here, if the wavelength is much smaller than the slit width here, you can see it's still spreading out, but the angle at which it's spreading out, the amount of spreading out, is not as large as you can see when the wavelength and the gap size are roughly equal. Now here we can have the wavelength, which is the gap size is much bigger. So again, it's still spreading out, but not as much as if the gap size and the wavelength are roughly equal. Okay, in this image, the gap size is much smaller than the wavelength, so the diffraction taking place is not as large. Also, the amount of waves going through is much less, so the intensity on the other end would be much lower.